Here are 32 practice problems on measure center, so mean, median, mode, and all that stuff. As per usual, I'll link the questions and the answer key in the description, so if you want to work ahead, you can go and do so. Or if you ever need a little more help, I will be going through every single question. Also, if you're still not sure, you can always ask me, you can always message me or something like that. But yeah, anyways, let's get started with question number 1. The box plots summarize the masses in kilograms of two groups of gazelles. Based on the box plots, which of the following statements must be true? So here we have two box plots, and you need to remember that from box plots you can only get three things. The first one is the minimum value, which is going to be this left line right here. Oops, there you go. The second thing is going to be your median, which is this middle line. And then your third thing is going to be your maximum, which is going to be this right line. So that is all you're going to be able to get from box plots. So let's start going through our answer choices. The mean mass, I'm gonna just stop right there. You cannot get mean from box plots. So A is gonna be wrong, and so is B. The median mass of group 1 is greater than the median mass of group 2, and let's check. This is the median mass of group 1 right here, which looks like it's on 25, and the median mass of group 2 looks like it's on 24. So 25 is greater than 24, so C is going to be our answer. And then D, it just says the opposite, so it's wrong. Question number 2. The table above shows the distribution of ages of the 20 students enrolled in a college class. Which of the following gives the correct order of the mean, median, and mode of the ages? So here we need three pieces of information: the mean, the median, and the mode. And if you remember, you can find the mean and the median in desmos. So oh shoot, let me quickly pull up desmos. Alright, here I am on desmos, and of course the first thing you want to do is put in your list. So choose any capital letter equals to, and then the bracket, and now let's start typing in our numbers. So here it says there's 6 18s, so 1, 2, 3, 4, 5, 6. There's 5 19s, 1, 2, 3, 4, 5. 4 20s, 1, 2, 3, 4. 2 21s, 1, 2. 122, 123, and 130. It also says there's 20 students, and here there's 20 elements, so that does match up. Now let's find our mean by typing in mean L, and we get that the mean is 20. Let's find our median, median L, and we get that our median is 19. So mean is equal to 20, and median is equal to 19. Now we can't find mode in desmos, but to find a mode, it's just gonna be the number with the highest frequency. And here, 6 is our highest frequency, and the number is going to be 18. So our mode is 18. And now let's look at our answer choices and see what matches. The mode is less than a median, that's right, which is less than a mean, and that's also right. So our answer is A. Question number 3. The frequency table summarizes the 57 data values in a dataset. What is the maximum data value in the dataset? Alright, this one's gonna be really easy. All we have to do is find the highest data value. So here are our data values, and we'll just look for the biggest number. And the answer, well, the biggest number is 14, so our answer is literally just 14. Question number 4. The results of 2 independent surveys are shown in the table below. Which statement is true based on the table? Alright, the question gave us nothing to work with, so let's just read our answer choices. The Group A dataset was identical to the Group B dataset. Well, if we look, they do have the same sample size, and they also have the same mean. However, they don't have the same standard deviation, so A is not our answer. Group B contained the tallest participant. Well, none of this actually gives you the maximum value or the tallest participant, so B is not our answer either. C. The heights of the men in Group B had a larger spread than the heights of the men in Group A. Well, if you remember, spread also means the same thing as standard deviation. So, did Group B have a higher standard deviation than Group A? It did, so our answer is C. Now let's just check D for funsies. The median height, I'm gonna just stop right there. Nowhere here did it give us the median, so D is not our answer either, so our answer is C. Question number 5. Dataset A consists of 10 positive integers less than 60. The list shown gives 9 of the integers from dataset A. The mean of these 9 integers is 42. If the mean of dataset A is an integer that is greater than 42, what is the value of the largest integer from dataset A? Now I know that was a lot to take in, so let's break this down. We know that we have this dataset A that has 10 positive integers less than 60. And I just want to quickly point out that an integer is a number that doesn't have decimals. So if we had the number 41, that would be an integer. But if it was 41.1, since it has a decimal, that's not an integer. Alright, then it gives us this list that has 9 of the integers from dataset A. So this list right here is missing one extra number. We know that the mean of these 9 numbers is 42, and that the mean of dataset A is an integer greater than 42. So all 10 numbers is going to have a mean that is greater than 42 and doesn't have decimals. Then it asks us to find the value of the largest integer from dataset A. So we're going to have to find the number, the very last number, that makes this list have a mean that is greater than 42 and it's not going to have decimals. So to do that, let's put this list into desmos and find the mean. So A equals, and now I'm typing all our numbers, 345. Oops, I messed up. 38, 39, 40, 46, 40. And then I'm gonna do the mean of A. Oops. And we get that the mean is 42, which does match up with what the question said. Now, we know that all 10 numbers have to be less than 60, and we want to find the largest number, so I'm gonna start counting backwards from 59. Now, if I do 59, you'll see that the mean is 43.7, which is greater than 42. However, it has a decimal, and that's not an integer. So we're gonna have to keep going. 58 has a decimal, 57 also has a decimal, 56, 55, 54, 53. Then we have 52. 52 doesn't have a decimal, and 43 is greater than 42. So our answer is gonna be 52. Question number 6. The mean and the median of the 5 numbers above are equal. Which of the following is not a possible value of x? So for this question, we're going to try putting all of these numbers in to this list, and then we're going to find the mean and the median, and we're going to check if they match up. So let's go ahead and put this list into desmos. L equals bracket 15, 14, 18, 17, and I'm going to just leave this last little number as a variable, and you can't put x or y as a variable, so I'm gonna just use a. Alright, now I'm gonna add a slider, and then real quick, mean of L and then median of L. And now I'm gonna just change this slider to these answer choice. I just dropped my water bottle, oopsies. Alright, anyways, I'm gonna change this value to my answer choices. So first we have 6, oops, that's not 6, so here I have 6, and these two are not the same. So that's what we're looking for, one that's not the same. So our answer is A. I'll keep going for fun though. Alright, 11, they are the same. 16, they are the same. And 21, they are the same. So our only answer is A. Question number 7. Dataset A and dataset B each consist of 27 values. The table shows the frequencies of the values for each dataset. Which of the following statements best compares the means of the two datasets? Now, since we're finding means, you could go and plug this into desmos to find the mean. Except you'd have to plug in, well, you have to plug in 27 values twice, because there's 2 lists. So you have to plug in 54 numbers, and that's just a whole bunch of typing. But for this, you could also use a little bit of common sense. So here, you'll see that for dataset A, there's going to be 9 46s. Whereas for dataset B, there's going to be 9 30s. Now just ask yourself, if you scored 109 times, whereas your friend scored a 79 times, who would have a better average? It's going to be obviously you who scored the 109 times, because 100 is higher than 70. So the same rule applies here, 46 is bigger than 30, so the mean of dataset A is just going to be greater than the mean of dataset B. Question number 8. A dataset of 27 different numbers has a mean of 33 and a median of 33. A new dataset is created by adding 7 to each number in the original dataset that is greater than the median and subtracting 7 from each number in the original dataset that is less than the median. Which of the following measures does not have the same value in both the original and new datasets? Now once again, that was like a whole chunk of words, so let's break this down. We have this dataset that has 27 different numbers and they have the same mean and median. So the mean is equal to the median. Mean equals median. This also means they have symmetric distribution, but I don't think that's important. Anyways, then they have a new data set where they added 7 to each number that is greater than the median, and then they subtracted 7 from each number that is less than the median. So whenever you have something as big as just a data set of 27 different numbers, you can just make up your own list. Now, one thing you do want to keep in common is that this has an odd number of elements, so I'm going to keep that true too. I'm going to make a list of, let's say 5 numbers, alright, because that's odd. Alright, then they added 7 to each number that is greater than the median, so they added 7 to 4 and 5 here. And then they also subtracted 7 from everything that's less than the median, so subtract 7 from 1 and 2. Now, one thing I do want to notice here is that the median here, or 3, it never changes. So that means that something that didn't have the same value, it's not going to be the median because the median stayed the same. And we also note that the mean right here is also equal to the median. So that means that the mean also didn't change. So we can get rid of A and B. Now, the next thing is that if you subtract the 7 here and add a 7 here, technically, these two would just cancel out. And then these two would also cancel out, which means that the sum of the numbers, they also didn't change. So C is not our answer, which means we're only left with D, which is the standard deviation. Now, let's say I didn't cross these out and I really did add them up. So this would be what? Oh shoot, -6, -5, 3, 11. Oh wait, 3, 11, and 12. Now, this goes from -6 to 12, whereas this only goes from 1 to 5. Now, I think it's pretty obvious, but this one definitely does have a greater standard deviation, so D would make sense. Let me also just quickly prove all of this in desmos. So here I have 1, 2, 3, 4, and 5, which is my original list. Then I have my altered list, which is -6, -5, 3, 11, and 12. Oops, I forgot to name these. Hold on. L equals, and then A equals. Alright. Now I'm gonna find the mean of L and the median of L. Then I'm gonna find the mean of A and the median of A. And as you can see, they're the same. So that will get rid of A and B. Now let me find the sum. So 1 plus 2 plus 3 plus 4 plus 5 is 15. -6 plus -5 plus 3 plus 11 plus 12 is also 15. So those two would also be the same, so C is not our answer. Then let me find the standard deviation of L and the standard deviation of A. And as you can see, the standard deviation of A is greater than L, so they're not the same, so our answer would still be D. Question number 9. The table above shows the... Okay, that's so many words, I'm skipping that. Based on the information given in the table, how much greater in millions was the median number of international tourist arrivals to the top 9 tourist destinations in 2013 than the median number in 2012 to the nearest tenth of a million? So here, all they're asking you is to compare the median of this column right here to this column. Now, you could go and put this in desmos, but that's what, this is 9 right here, and this is also 9, so that's 18 numbers I have to type. That's too many numbers, alright? So instead, since this is actually ordered from greatest to least, you could just find the middle number. So I'm gonna start crossing off stuff, alright? Alright, and then we get that our median is gonna be this right here, and then we just have to find how much greater it was, so just 47.7 minus 46.4, which is 1.3. So our answer is 1.3. Question number 10. Which of the following statements must be true? The median of dataset A is equal to the median of dataset B. The standard deviation of dataset A is equal to the standard deviation of dataset B. Now, if you look at these dot plots, you notice that they're actually symmetrical. 1, 1, 4, 4, 2, 2, and your center. So 13 is your median because it's the center. 2, 2, 4, 4, 2, 2, and 1. Once again, 13 is your median because it's the center. So the median of dataset A, which is 13, is equal to the median of dataset B, which is also 13. That is true. Next up, you also notice that dataset A is more clustered compared to dataset B, which is more spread apart. This means that dataset A, of course, has a smaller standard deviation compared to dataset B. So the standard deviation will not be equal. So 2 is not true. So your only right answer is going to be A. Now, you could also check the median if you didn't know that it was symmetrical by crossing it off. And you see that you still just end up with 13. And for dataset B, you'll also end up with 13. Now, let me also show you in desmos. Alright, dataset A. And then dataset B. Now, if we check the mean of both of them, or the median, sorry, I don't know what I'm thinking. Mean of A and median of B, you'll see that they're both 13. And as for the standard deviation of A, it's that, standard deviation of B. They are different, so once again, our answer is A. Question number 11. Two datasets of 23 integers each are summarized in the histogram shown. For each of the histograms, the first interval represents the frequency of integers greater than or equal to 10, but less than 20. The second interval represents the frequency of integers greater than or equal to 20, but less than 30, and so on. What is the smallest possible difference between the mean of dataset A and the mean of dataset B? Now that was also like a whole chunk of words right there, so let's break this down. We have two datasets with 23 integers each, so we have dataset A here and dataset B here. Then we know that for these intervals, they're going to be greater than or equal to 10 but less than 20, greater than or equal to 20 but less than 30. And all that means is that for this little interval right here, oh, I messed up. This interval right here, it's going to be between 10 and 19. And then between this interval right here, that's going to be between 20 and 29. This right here is 30 and 39. This right here is 40 and 49. And this right here is 50 and 59. Then for dataset B, the same thing applies. Oh, let me erase all this real quick. Okay, so once again, this interval right here, that could be any number between 10 and 19. And then this one is between 20 and 29. This one is between 30 and 39. This one is between 40 and 49. And then this one right here would be between 50 and 59. Now, they're asking us to find the smallest possible difference between the mean of dataset A and the mean of dataset B. So we're going to have to find the mean of dataset A and the mean of dataset B and then subtract them. Now, before we do that, the first thing you should notice is that dataset A here has 9 numbers in this column of between 50 and 59, whereas dataset B has 0, alright, there's nothing here. And that just means that the mean of dataset A is going to be greater than the mean of dataset B. Now we're going to have to find the mean of dataset A and dataset B. But the problem is, well, what number are we supposed to use, right? I mean, it could be between 10 and 19. Well, I guess we're not using this one. But let's say for this very last one, it could be any number between 50 and 59. So would we choose 50 or 51 or 52 or 55 or 59? So we do know that dataset A is going to have a higher mean than dataset B. and want to find the smallest possible difference between them. This basically means that we want to set the mean of dataset A to the lowest it possibly could, and we want to set the mean of dataset B to the highest it possibly could. This means for all these intervals, we're going to use the lowest possible number. So for this one, the lowest would be 20, the lowest for this one would be 30, the lowest for this one would be 40, and the lowest for this one would be 50. Then as for dataset B, the highest for this one would be 19. The highest for this one would be 29. The highest for this one would be 39. And the highest for this one would be 49. So with all that being said, let's start finding our mean. Now, this one requires you to put 23 numbers out, and I'm not gonna lie, I don't think I want to do that in desmos, so I'm gonna do something a bit different. First things first, we know in this interval there's 3, and then this one there's 4, this one there's 7, and this one there's 9. And as for dataset B, 3, 4, 7, and 9. Now I'm gonna just start multiplying it out. So we know we have 3 and we want to use the lowest, so 3 times 20. Let me type this out. For dataset A. Alright, so we're gonna have 3 times 20, which equals to 60. Then we have 4 times 30, and that's gonna be 120. And then we have 7 times 40, 280, and 9 times 50, which is 450. Now we're gonna add that all up and divide that by 23, because there's 23 integers. Is equal to 910. Divide that by 23 is 39.5 or 39.6. Divided by 23 is equal to 39.6. Then for dataset B, what's happening? Dataset B, it's gonna be 3 times, and we want the highest for this interval, so 3 times 19, and then 4 times 29, 7 times 39, and 9 times 49. Then we're gonna add that all up. Oh, hold on. 57, 116, 273, and 9 times 49 is 441. Now let's add that all up. Is 887, and we're gonna divide that by 23. And we get that the mean of dataset B is 38.6. So the difference between 39.6 and 38.6 is 1. So our answer would be B. Now, the reason I chose the lowest possible number for dataset A, where here in this interval, I could have chosen any number between 20 and 29, but I decided to use 20 to find the mean. And for dataset B, I chose the highest possible number. So here I could have chosen any number between 10 and 19, but I decided to use 19, as you can see here, to find our mean, is because let's say I had chosen a smaller number for dataset B. So dataset B, instead, let's say I use 10. Alright, so 3 times 10 would be 30. And as you can see, 30 is smaller than 57. And then let's say I chosen 20 for this next one. 80 is smaller than 116. Which means I would end up getting a mean that is smaller than 38.9. So let me put this on a number line real quick. So I have this number line right here. And we know that the mean of dataset B is 38.6. And had I chosen any smaller number, my mean would have just gone smaller. So my mean would end up going this way for the mean of B. Alright? And for dataset A, let's say I chose any larger number than 20. So let's say I chose 29 instead. Dataset A. 3 times 29 is 87. 87 is larger than 60. And then 4 times 39 would be 156. Now as you can see, this would result in getting a larger mean than 39.6. So the mean of dataset A is 39.6. 39.6, I know that's hard to read. But had you chosen any larger number, that means our mean would only be getting bigger. Or it would be going this way. Mean of A. Now, we want to find the smallest possible difference, so we want our two means to be as close together as possible. And the only time that happens is right here when we chose the highest possible value for B, and right here where we chose the smallest possible value for A. That means when you get these types of questions, you want to choose the smallest integers for the one with the higher mean, which is data set A, and you want to choose the highest integers for the ones with a smaller mean. Or you could just skip it. Like, to be honest, that question took a lot of time. So if you get this type of question, you'd probably be better off just skipping it and then coming back to it at the end if you have the time. Question number 12. The frequency distribution above summarizes a set of data, where A is a positive integer. How much greater is the mean of the set of data than the median? Now, before we actually try and do anything in Desmos, let's look at this table. You notice that here it goes from A, then 2A, 2A, and then you have your center. So this is symmetric. That means that our mean is equal to our median. So how much greater is the mean compared to the median? Well, they're both the same. So our answer is A, where there's zero difference. Question number 13. Two different teams consisting of 10 members each ran in a race. Each member's completion time of the race was recorded. The mean of the completion times for each team was calculated and is shown below. So Team A had an average time of 3.41 minutes, and Team B had an average time of 3.79 minutes. Which of the following must be true? Every member of Team A completed the race in less time than any member of Team B. Well, this one isn't going to be true because, yeah, Team A was overall faster, but we don't know the individual time for each and every member, so we can't say this. Number 2. The median time it took for the members of Team B to complete the race is greater than the median time it took the members of Team A to complete the race. Well, once again, all we get from here is the mean time or the average time. There's no way for us to find out the median time if we don't have each member's time. So we can't assume 2 either. Then number 3, there is at least one member of Team B who took more time to complete the race than some member of Team A. And this would be true because if there's at least one person that took more time, that would result in Team B having a slower average. So the only possible true answer is going to be 3, or our answer choice would be A. Question number 14. The mean score of 8 players in a basketball game was 14.5 points. If the highest individual score is removed, the mean score of the remaining 7 players becomes 12 points. What was the highest score? So let's break this down. We know that the mean of 8 players was 14.5. And if you remember, mean is equal to the total divided by the number of numbers. So in this problem, the mean, which is 14.5, would be equal to the total points of all 8 players divided by the number of players, which would be 8. So to find the total points, all we have to do is multiply both sides by 8. Multiply both sides by 8. And we get that the total number of points was 116. So 14.5 times 8 is equal to 116. Then we note that they removed the highest individual score and their new mean of 7 players is 12. So our new mean, which is 12, is equal to the total points divided by the number of players, which is 7. And once again, to find the total points, we're going to multiply the entire thing by the denominator, which is 7. And 12 times 7 is 84. So 12 times 7 is equal to 84. Now, we know we got this number of points, which is 84, by subtracting the highest score from this number of points. So that means that 116 minus x, which is the highest individual score, is equal to 84. And now, to find the highest score, all we have to do is solve for x. And you could solve for x, however, but really it's just 116 minus 84, which is equal to 32. So our answer is C. Question number 15. In the table above, Melissa recorded the price of 1 gallon of regular gas from 5 different local gas stations on the same day. What is the median of the gas prices Melissa recorded? Now, normally you would just go crossing things off until you get a station 2 and think that's your median. But you also have to remember to find the median, it's the middle of an ordered set of data. But if you look at these prices are not ordered. I mean, it goes from a high price to a lower price, back up to a higher price. So first things first, you're either gonna have to rearrange all of these prices in least to greatest, or you could just put it into desmos. I'm gonna just rearrange them. So we have station 2, and then station 4, and then station 1, and station 3, and station 5. Now our median is just gonna be the price of station 1, which is 3.699, so our answer is C. Alright, I lied. I'm gonna do in decimals as well, just for funsies. So L equals. Alright, there we go. That's all of the prices in. Then you're gonna do median L, and you get that the median is 3.699, which is the same as C. Question number 16. For which of the following datasets is the mean greater than the median? To be honest, no better way to do this than just put them into desmos and see which one has a bigger mean than median. However, first things first, these two are actually symmetric. So we know that the mean is going to be equal to the median, so it's not going to be A or B. So all we have to put in is C and D. Alright, that's all of C, and let's find the mean of C, and then the median of C. And here we get that the mean is 113, and the median is 32. So the mean is greater than the median, and our answer will be C. Question number 17. The table shows the frequency of values in the dataset. What is the minimum value of the dataset? So they're asking for the minimum value. Here are values. And which value is the lowest? Well, it's gonna be 19. So our answer is just 19. Now be really careful not to mix this up with frequency. You know, here it specifically says value. So you should be looking at the value only, alright? Pretend the frequency doesn't exist. Question number 18. Each of the dot plots shown represents the number of glue sticks brought in by each student for two classes, Class A and Class B. Which statement best compares the standard deviations of the numbers of glue sticks brought in by each student for these two classes? Now here they're talking about standard deviations and dot plots. So if you remember, the more clustered a dot plot is, the smaller the standard deviation, and the less clustered or more spread out a dot plot is, the greater the standard deviation. But if we look at these two dot plots, they look the exact same. I mean, we have 1, 1, 1, 1, 3, 3, 4, 4, and so on and so forth. So that means to say, if they look the exact same, that means they also have the exact same standard deviation. So our answer is B, where the standard deviation is equal to the standard deviation. Now, even though these have different numbers on the bottom, here it's 1 through 7, and here it's 14 to 20, that doesn't matter. All we're looking at is going to be the shape of the dot plots themselves. Question number 19. Each of the following frequency tables represents a dataset. Which dataset has the greatest mean? Now you could go and calculate the means for each and every one of these, but there's also a pattern that you can notice. So here let's start backwards. Let's look at D. The frequency of this number and this number, they're both the same. And then the frequency of this number and this number is also the same. So this means that this dataset is symmetric around a central point. And we can basically guess that the center point is going to be somewhere right here. So it's going to be somewhere between 80 and 90. And then the same goes for C. This one is the same, this one's the same, this one's the same, this one's the same, which means we can guess that the center point is going to be somewhere around here. Or if we look between 80 and 90. Now this means that the frequency tables of C and D are going to have the mean of some number between 80 and 90, so 85 and 85 here. Then for B, this one has the same frequency values for all of them, so you could technically say it's also going to be 85. But here if we look at A, the frequency value is always increasing, so we could guess that A is going to have a bigger mean than 85. So here our answer would be A. Now this method requires a lot of thinking, so you could always just be doing 70 times 4, 80 times 5, 90 times 6, 100 times 7, then add that all up and divide that by the total to get your mean. I did go ahead and calculate the means of all these tables, and you can see that B, C, and D, which are all symmetrical, have the exact same mean of 85, and then A has a slightly larger mean of 87. Question number 20. The mean amount of time that the 20 employees of a construction company have worked for the company is 6.7 years. After one of the employees leaves the company, the mean amount of time that the remaining employees have worked for the company is reduced to 6.25 years. How many years did the employee who left the company work for the company? Alright, how many times did I just say company? But anyways, this is gonna be like the exact same thing as that one with like the basketball and the points and whatever. So we know that the mean, oh, that's super. Okay, the mean of 20 employees is 6.7. So 6.7, which is our mean, is equal to the total years divided by the number of employees, which is 20. So to find the total number of years of all 20 employees, all we have to do is multiply this entire thing by the denominator, which is 20. So 6.7 times 20 is equal to 134. And then we know that some random guy leaves, and now the mean is 6.25. So 6.25, which is our new mean, is equal to the total years minus that one random guy over the total number of employees, which is now 19. And to find the total number of years without that random guy, all we have to do is multiply by the denominator, which is 19. Oops, 19. So 6.25 times 19 is equal to 118.75. So that means that 134 years minus that one random employee who left is equal to this new number of years, which is 118.75. So to find the total number of years that this guy worked, all we have to do is 134 minus 118.75, which is equal to 15.25. So our answer is D. Question number 21. The weights in pounds for 15 horses in a stable were reported, and the mean, median, range, and standard deviation for the data were found. The horse with the lowest reported weight was found to actually weigh 10 pounds less than its reported weight. What value remains unchanged if the four values are reported using the correct weight? So we know we have these 15 horses, and they found the weights of each horses. However, there's this actual one horse that weighed 10 pounds less. And now we're trying to find, did the mean, median, range, or standard deviation not change? So which one didn't change? First up, the mean. Well, the mean is equal to the total number of pounds divided by those 15 horses. And since one of them weighed 10 pounds less, is the total going to change? Or is the mean going to change? The answer is yes, so it's not going to be our mean. Then we have our median, which is just the middle number or the middle value of all 15. And is the middle value going to change? No. I mean, the very first value changes, but not the middle. So our median does stay the same. And our range. Our range is equal to our maximum minus our minimum. And then here it says that the lowest reported weight is 10 pounds less. So our minimum actually changed, which means that our range does not stay the same. And then of course our standard deviation does not stay the same as well because our mean changed, and that means that the spread of data is going to be larger. Question number 22. Which of the following statements about the means and medians of dataset A and dataset B is true? Now you could go plugging these two datasets into Desmos and find the mean and median, or you could use a little bit of thinking. So here we have dataset A, and dataset B looks the exact same, except at the very end they added 100. So we know for sure that the mean of dataset B is gonna be greater than dataset A because there's this whole extra 100 right here. So we can get rid of B and D. Then we know that the median is the average of the two middle numbers if there's an even number of elements, or just straight up the middle number. And if we look at both the datasets, even if I cross out a little bit at the end, the middle is still going to stay the exact same, which means that our median is going to stay the exact same, or 5. So the only thing that is different is going to be A, which is the means. Alright, I did go ahead and plug datasets A and B into Desmos, And as you can see, the mean is different, whereas the median stays the same. Question number 23. The dot plot represents the 15 values in dataset A. Dataset B is created by adding 56 to each of the values in dataset A. Which of the following correctly compares the medians and the ranges of datasets A and B? So here we have this dot plot with 15 values, and then we're going to create a new dot plot where they added 56 to each value. So this would be 22 plus 56, so 78, and then it would be 1, 2, 3, 4, and then so on and so forth. Now they want you to compare the medians and the ranges. So first things first, the median is going to be the very middle number. So I'm going to just guess and say that it's going to be 24 here. But since we added 56, it would be something like 80 here. So it's kind of obvious that the median is going to be larger in dataset B than dataset A. So it's not going to be equal to. And then as for the range is equal to the maximum minus the minimum. So here, this would be 26 minus 22, which is 4. Whereas here, it would be, whatever 26 plus 56 is. So 26 plus 56 is 82. And 22 plus 56 is of course 78. So our range actually still stays the exact same at 4. So that means that our range is equal to, and our answer will be C. Question number 24. If A is the mean and B is the median of 9 consecutive integers, what is the value of the absolute value of A minus B? So here, when they give you something as big as this 9 consecutive integers, just make up your own numbers. So I'm gonna make a list of like 1, 2, 3, 4, 5, 6, 7, 8, and 9. And if you look, this actually means that it's symmetrical. So the mean and the median are equal to each other, which means that the mean minus the median is just 0. Or of course, you could put it into desmos to find out. As you can see, the mean and the median are the exact same. Now let's say I chose some other random numbers. So let's say I chose like, let me do like, I'm gonna start counting from 199 just for funsies. And as you can see, the mean and the median will still say the exact same. Question number 25. Dataset A consists of the heights of 75 objects and has a mean of 25 meters. Dataset B consists of the heights of 50 objects and has a mean of 65 meters. Dataset C consists of the heights of the 125 objects from datasets A and B. What is the mean in meters of dataset C? Now, I know that was like a whole another like load of information, so let's break this down. We know that dataset A has the heights of 75 objects and a mean of 25 meters. So that means that for dataset A, the mean, which is 25, is equal to the heights, which we don't know, of all the objects divided by the number of objects, which is 75. And let's go ahead and find our heights, and to that we just have to multiply the entire equation by 75. So 25 times 75 is equal to 1875. Then for dataset B, it has the heights of 50 objects and a mean of 65 meters. So the mean 65 is equal to the heights, which we don't know, divided by the number of objects, which is 50. And once again, to find the heights, we just have to multiply the entire equation by its denominator, which is 50. So 65 times 50 is equal to 3,250. Now we want dataset C, and we know it has the heights of the 125 objects from datasets A and B. And they're asking us for the mean. So we know that the mean is equal to the height of datasets A and B, and we do have the heights. We know that the height of dataset A is that number, and the height of dataset B is this number. So let's add them up. Divided by the number of objects, which is 125. And if we go ahead and calculate all of that, we get that the mean of dataset C is equal to 41. Question number 26. Dataset F consists of 55 integers between 170 and 290. Dataset G consists of all the integers in dataset F, as well as the integer 10. Which of the following must be less for dataset F than dataset G? And we have the mean and the median. So here we have dataset F, and it has 55 numbers between 170 and 290. Then we have dataset G, which has the exact same numbers but also 10. So if it has this extra number 10, we know that for sure the mean is going to be smaller. So the mean of G is less than the mean of F. Now as for the median, we know that dataset F has 55 integers. So that's an odd number of elements, which means the median is going to be that very middle number. Whereas dataset G is going to have one extra integer, so it's going to have an even number of elements. So that means that the median is going to be the average of the two middle numbers. That means that the median of dataset G is either going to be less than or equal to the median of dataset F. So, which of the following must be less for dataset F than dataset G? Well, both of these, dataset F is going to be greater, so the answer is going to be none of them. Question number 27. Dataset A consists of the heights of 75 buildings and has a mean of 32 meters. Dataset B consists of the heights of 50 buildings and has a mean of 62 meters. Dataset C consists of the heights of the 125 buildings from datasets A and B. What is the mean in meters of dataset C? Alright, this is like the exact same question as 25, except they changed from objects to buildings and changed up the mean. Alright, we can do the exact same thing. So for dataset A, we know that the mean is 32, which is equal to the heights of all the buildings, which we don't know, divided by the number of buildings, which is 75. So to find the heights, we just have to multiply the entire equation by the denominator, which is 75, and 32 times 75 is equal to 2,400. And then for dataset B, we know that the mean, which is 62, is equal to the heights, which we don't know again, divided by the number of buildings, which is 50. And to find the height, we're just going to multiply the entire equation by the denominator, which is 50. So 62 times 50 is equal to 3,100. And then for dataset C, the mean, which we don't know, is equal to the heights of datasets A and B. And the height of dataset A is that number, and the height of dataset B is this number. So 2,400 plus 3,100 divided by the number of buildings, which is 125. And if we go ahead and do the math, the mean is equal to 44. Question number 28. A survey was given to residents of all 50 states asking if they had earned a bachelor's degree or higher. The results from 7 of the states are given in the table above. The median percent of residents who earned a bachelor's degree or higher for all 50 states was 26.95%. What is the difference between the median percent of residents who earned a bachelor's degree or higher for these 7 states and the median for all 50 states? Alright, once again, that was a whole another chunk of words, but here they're asking us for the difference between the median percent of 7 states and the median of 50 states. So first, let's find the median of the 7 states. And we know that it's going to be in this table right here. And if we look, dang it, it's not ordered. So we're either going to have to order it or put it in desmos. I'm going to just quickly order it. Alright, and now we're just going to find the median, which is going to be state B, which is 27.9%. So 27.9 is going to be the median of 7 states, and then the median of 50 states is 26.95, so let's subtract that. And 27.9 minus 26.95 is 0.95, so our answer is B. And we get that the median is 27.9, which is the same as what I got. And 27.9 minus 26.9 is 1. Wait, 26.95. Alright, I missed the 5. Alright, 26.95 is 0.95, so our answer is B. Question number 29. A fish hatchery has 3 tanks for holding fish before they are introduced into the wild. 10 fish weighing less than 5 ounces are placed in tank A. 11 fish weighing at least 5 ounces but no more than 13 ounces are placed in tank B. And 12 fish weighing more than 13 ounces are placed in tank C. Which of the following could be the median of the weights in ounces of these 33 fish? So we know we have 10 fish weighing less than 5 ounces in tank A. So tank A is equal to 10 fish less than 5 ounces. Then we know that tank B has 11 fish between 5 and 13. At least 5, but no more than 13. Alright. And then we know that tank C has 12 fish weighing more than 13 ounces. So 12 fish weighing more than 13 ounces. Now we want to find the median of these 33 fish. And if you remember, to find the median, we're going to have to take the number of elements, which is 33, divide that by 2, which is 16 and a half. But we have to round that up to get 17. Which means that our median is going to be the 17th position of all of our numbers. And our 17th position is going to be somewhere in these 11. Which means that our answer is going to have to be between 5 and 13. And the only answer between 5 and 13 is B. Question number 30. The mean of the list of numbers above is what fraction of the sum of the 5 numbers? So, the mean, right, is equal to the sum of numbers divided by the number of numbers. So, that means that the mean is equal to the sum of the numbers, which is going to be 25 divided by 5. Or, if we know 25 divided by 5, that's just 5. So, 5 compared to, which is our mean, compared to our sum of numbers, which is 25, is just 1/5 of 25. So our answer is 1 over 5. Now, you also could approach this question a little bit differently, where we know that the mean is equal to the sum divided by the number of numbers. And here in this list, there's 5 numbers, so the mean is equal to the sum over 5, or the mean is just what fraction of the sum of 5 numbers? Well, it's gonna be 1 over 5. Question number 31. Andrew and Maria each collected 6 rocks, and the masses of the rocks are shown in the table above. The mean of the masses of the rocks Maria collected is 0.1 kilogram greater than the mean of the masses of the rocks Andrew collected. What is the value of x? So here, we're gonna find the mean of Andrew's rocks, and then we know that the mean of Maria's is gonna be 0.1 greater. And then after that, we're gonna have to find the value of this missing number. So first, let's go ahead and find the mean of all of Andrew's rocks. So Andrew is equal to, and then the mean is equal to 2.8. Now we know the mean of Maria's rocks is gonna be 0.1 greater, so 2.8 plus 0.1 is 2.9. Now let me make a list for Maria's rocks. So M is equal to, and I'm gonna choose any random letter, so A, and then the mean of M. Now, we know that this mean needs to match up with 2.9, so I'm gonna just keep scrolling until it reaches 2.9. Oh, 2.96, I went over. Oh, 2.93, hold on. 2.9, 2.7, 2.6, oh, there we go. We get that when A is equal to 2.6, our mean is 2.9, so this missing number is going to be 2.6. Question number 32. For a certain computer game, individuals receive an integer score that ranges from 2 through 10. The table below shows the frequency distribution of the scores of the 9 players in Group A and the 11 players in Group B. The median of the scores for Group B is how much greater than the median of the scores for Group A? So first, normally you would think that, oh look, just go to the middle of the table and then subtract that, but we can't do that. And that's because there's 9 players in Group A and 11 players in Group B. So they don't have the same number of players. Instead, let's just go ahead and write out our list. So we know for Group A, we have 1 2, 1 3, 2 4s, 1 5, 3 6s, no 7s, no 8s, 1, 9, and no 10s. And then as for group B, we have no 2s, no 3s, no 4s, 4 5s, 1, 2, 3, 4, 2 6s, no 7s, 2 8s, 1 9, and 2 10s. Now let's just find the median of the both of these. Oh, I just realized if I was gonna type it out, I should just put in desmos. Okay, the median of group B is 6. And then for group A, the median is 5. So 6 minus 5 is equal to 1. So our answer is just 1. Alright, well, that was 32 problems on measure of center, so mean, median, mode, and all of that. And I think it's really obvious that most of these questions you can do in desmos. Like this one you can, that last one you can. This one you could too. But you also notice that for a lot of them, if you go like the thinking route, then it's gonna be a lot faster. Except thinking is hard, and like I don't like thinking either, so you can always just be safe and put it in desmos. But other than that, I guess just really make sure you remember what mean, median, and mode, and all of that stuff is, and you should be fine. Alright, and with that, I'll see ya.